Well, hello guys, here Mr. G with another video for the grade 10. This time we're going to be practicing a question on naming compounds and writing the formula of compound. This is paper 2 done in the Northern Cape in 2013. It was set B and we're going to answer question 5. But before that, subscribe for the channel so you can get all the notifications and videos I post on a regular basis. This question says no matter how compound is prepared, it will always contain the same element in the same proportion by mass, and that is called the law of constant composition. It's an important law. I'm going to highlight it. It will always compounds will always contain the same element in the same proportion by mass, and that is the law of constant composition. Write down the correct chemical formula for each of the following compound, and the first one is iron 2 sulphide. Alright, so for this work, the first thing you need to do is to learn the ion. There is a table of ions, and ion 2 will be Fe2 plus, and sulphide, if you go there, it will be a S2 minus. You must go to the table of ions. It is important. And now what is going to happen here is that these numbers are going to change places without the signs. So let's take off that circle there and just write the number. The numbers are going to change places. In other words, this 2 is going to move to this side here, and this other 2 is going to move on that side there. So you will actually have Fe2 S2. But if the numbers on these sides are the same, and as it is the case, then they simplify each other and you will have FeS. This is the formula for the compound iron 2 sulphide. Let's go to question 5.1.2. Now, question 5.1.2 is lead 2 nitrate. Now, for lead 2 nitrate, you need to know that lead 2 is going to be Pb2 plus, that is lead 2. And nitrate, which is a very important ion here, is going to be NO3. Now, the 3 is only for O, but this minus here is for everything. So I'm going to do it in brackets so you understand what I'm saying. So this minus here for the entire ion, guys. So now the numbers, the same rules as we applied before here. These numbers here, in this case is a 1, are going to swap places. This one is let me don't get you guys confused thinking is a 0. That one is going to move to that side there, and this 2 is going to move to that side, but all out of the bracket there. All right, so the final answer here will be Pb1, because it's coming from this ion, NO3 bracket 2 from the Pb. This is the formula for lead 2 nitrate. I hope it's understood. It's not that bad. Let's go to question 5.1.3. Question 5.1.3 is calcium carbonate. Now, for calcium carbonate, the symbol for calcium ion is going to be Ca2 plus. You must remember that all the elements in group 2 from the periodic table will form ion of 2 plus, and carbonate is going to be CO3, and the same as nitrate, there is a negative 2 or 2 minus, but that is for everything, guys. That 2 minus is for everything, not only for the oxygen. And as the rules say, they're going to swap places. In this case, there are 2 2's here. I think you got the idea now. So the formula will be Ca2 bracket CO3 bracket 2. But as we did in the first example here, if the numbers are the same, they cancel each other, and the final formula is going to be CaCO3. You don't have to make the bracket because the answer is with A1. So this one is calcium carbonate. Let's go to question 5.1.4. And question 5.1.4 is silver nitrate. Now, for silver nitrate, the symbol for silver ion is G positive 1. And nitrate, we already have it here on top, so it's NO3, is the NO3 with the bracket and 1 minus, in this case the same like 1 plus, okay, or positive 1. So now those numbers are going to switch places here, and you will have at the end Ag with the 1 of nitrate, NO3, everything with the 1 of silver. This one is quite simple, guys, and this one here is silver nitrate. I hope you understand. This one is question 5.1. Now, for question 5.2, they say give the correct name for each of the following compound, and they're giving you 2 compounds here. All right, now these compounds, the first thing we need to do is to identify the ions. Now, for the first one, the ions are here Na and HCO3. Those are 2 ions there. The Na is Na plus and is called sodium. And then the HCO3 is a minus there. Remember that minus, let's do it here just for you to know, that minus is for everything, and this is called hydrogen carbonate. So what is the name of this compound here? Is going to be sodium hydrogen carbonate. And that is the answer for question 5.2.1. Question 5.2.2. Now be careful here. We have to identify the ions there, and it may be slightly different here and tricky. The first ion here is Fe, and the second one is Cl. Now, if we go back to the tables of ion, you're supposed to know that Cl is a negative 1 and is going to be called chloride. That is the name of the ion, and it's Cl minus. Now, these 3 here, guys, the 3 you see there is coming from the ion. So if the ion have a 3 positive, so if it's a 3 positive like Fe3 plus, then this ion 3. And then the name of this compound together, all together, is going to be, we're going to write it here for 5.2.2, is going to be ion 3, the 3 must be there, ion 3 chloride. And that is the name of that specific compound. Question 5.2.3. Now we have sodium on this side. The sodium ion, guys, is already in question 5.2.1. It is the ion for sodium. And then the next one is iodide. It's iodide, and then iodide, you need to know that iodide, which is a I minus is called iodide. And then when you combine those 2 compounds there, this one is going to be question 5.2.3. We're going to write the compound right there. It's going to be sodium iodide. That is the name of that compound. There is quite simple. If we go to the last one, now this one here, guys, and is a very important compound. So I want you to learn this compound by heart. H2SO4 is sulfuric acid, but it also can be called hydrogen sulfate. So either one of them, sulfuric acid or hydrogen sulfate. I hope that one is clear. This is question 5.2. Is a very important question. Now question 5.3. Magnesium reacts with oxygen to form magnesium oxide. What type of bonding, covalent or ionic, took place when the product was formed? Now, this is magnesium and oxygen. Magnesium is a metal and oxygen is a non-metal. Oxygen is a non-metal. And you need to know that as a general rule, when a metal combines with a non-metal, that is going to form a ionic bonding. So if a metal combines with a non-metal, then the bonding is going to be ionic bonding. Alright, so that is the selection here. Ionic bonding, that is the answer for that question. Using Lewis notation to show how the positive ion is formed for magnesium. So now this one is quite simple. Remember, in the Lewis notation, you only use the valence electron. So now we have in magnesium, and magnesium have two valence electrons, 1 dot and 2 dots. And magnesium is going to lose those 2 electrons. It's going to be given the electron away, and therefore magnesium will become a 2 positive, which means it gave away those 2 electrons. And here we are going to represent the 2 electrons. The electrons cannot just disappear. The electrons are being there. So this is how to write or use Lewis notation to show the formation of that specific ion. Is quite simple. And now we have to use Lewis notation to represent the negative ion. Now we're talking about oxide. Now remember, oxide, guys, is a, if I'm going to write it here, oxide is a O2 minus. So how it is formed? We coming from oxygen, and oxygen have a Lewis or valence electron of 6 valence electrons. So it's 1, 2, 3 and 4, 5 and 6. This one is oxygen, but oxygen is going to gain the 2 electrons, and then when oxygen gains 2 electrons, it have now 8 valence electrons. So oxygen now, the new one, have all the 4 the valence electrons there, but it, because gain 2 electrons, it becomes negative 2 or 2 negative, which is what we call oxide. And this one is the formation of the oxide. And finally, the ionic crystal lattice is formed. Now this is the combination of the 2 of them, and we are going to do that one in this side here. This one is question 2.3. There we go there. The ionic crystal. So what we have the magnesium with the 2 valence electron, and you are going to add the oxygen with the 6 valence electron like we did before. There we go, 1, 2, 3, 4, 5 and 6. Now what is going to happen here, guys? Because it is ionic bonding, this valence electron of magnesium is going to be given away to the oxygen, as well as this other valence electron will be transferred to the oxygen. So now in the product we are going to have the magnesium without those valence electrons, and therefore is becoming 2 positive, and the oxygen is going to be having all the 8 valence electrons, 1, 2, 3, 4, 5, 6, 7 and 8, and it, because it gained those 2 electrons, is going to be a 2 minus. The square bracket is because the 2 minus there is for everything with the valence electron. And this one is how the ionic crystal lattice is formed. Draw the orbital block circle notation for the magnesium atom and magnesium ion. So let's do that one real fast. Okay, so we are going to have here the magnesium atom, and on the right side the magnesium ion. Now what you need to know for this about diagram, you need to know the valence electron for each of them, or the total number of electrons, not just the valence but the total number of electrons. So number of electrons for magnesium atoms. Now the magnesium will have a total of 12 electrons. Magnesium will have a total of 12 electrons. That is very important. But magnesium ion does not have 12 electrons. It has only 10 electrons because it gave 2 electrons away. So when you do the above diagram with all the circles, remember you have to start with one S. So you say one S, in there I'm going to draw one circle. Then you have 2S with another circle. You can use a square. 2P with 3 circles. Then it's coming 3S with another circle. 3P with another 3 circles. And 4S with 1 circle. And we have to represent here 12 electrons. Alright, so how does it work? You always start with the 1s and you are going to place the electron using half an arrow, one facing up and one facing down. There is 2 electrons, so it's 1, 2, 3 and 4. Now when you go to the peace orbitals, you make sure you place 1 electron in each orbital before you start or you go to the 3s. Like for instance, it is 4, 5, 6 and 7, and then if you have extra you go back to the first one. 8, 9 and 10. So in the 1s is 11 and 12. So this is the above diagram for the magnesium atom. Note the following: if you don't have enough electron, the 3p and 3 and 4s, this one here is the 4s, doesn't need to be represented. Now for the ions, you are going to do exactly the same. You are not going to go to 4p or 4d. The 4s will be enough for all the ones you have to learn. And now we have to represent 10 electrons. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And this is the above diagram for the magnesium ion here. And guys, this is the end of question 5. I hope you understand. I hope it helped. Thank you for watching. Thumb up, subscribe for the channel. I'll see you next time. Mr. G here.